Let's move into what is probably going to be the newer factoring process that you've not seen before. This is a process called factoring by grouping. And what factoring by grouping does is it breaks a set of terms up into two individual problems where we will factor out a common monomial as we go through the process. So if we look here, we kind of give you a funny looking problem in this factoring by grouping, and it's got four terms basically. Excuse me. So we've got four terms going on here. Now this is just for example purposes. You won't always have four terms. Sometimes you'll be factoring trinomials using grouping, but we want to show you the process here first, the grouping process. So what we're going to do is we're going to look at these four terms, and what we want you to recognize is this. The first two terms, ax plus bx, have a common term between them. We could actually factor out a common x. But in essence, we want to separate them or break those apart from the second group of a plus b. So what we're going to end up doing is we're going to end up breaking these into two separate individual terms. Now, if you look down here in the solution, we've used parentheses as a method of breaking them up. So what we've done is we've just put a set of parentheses like this as a procedural step to helping us break these up. And this is why it's called grouping, because we've taken the four parts and we've grouped them into two individual parts so that we can actually factor out a common monomial. Now what you'll notice is in the first one we have a common x that we want to factor out, which gave us x times a plus b. Well, what we're trying to do here with the second one is we're trying to factor out something as well that's going to leave us an a plus b. So we can factor out a common 1. Now this is an important step because this a plus b and this a plus b are now a common term in the bigger scenario. So we factored out an x from the first one, we factored out a 1 from the second one, and we were left in both cases with an a plus b. So let's take this term here and this term here, and if we look at this, both of those are terms of the bigger problem, and they both have a common a plus b between them. So what we're going to do is we're going to factor out the a plus b. And when we factor out the a plus b, we're left with simply an x from the first one, and we're left with a positive 1 from the second one, and we've in essence factored this four-term polynomial by grouping. Now, as always, if you wanted to double check this, you could simply FOIL a plus b back with x plus 1, and you would come up with the original term given in the example number 4. Now, this process of factoring by grouping is new and cumbersome at first, but after you do a handful of problems of factoring by grouping, it becomes easier and easier, and then in a lot of cases becomes the preferred method of factoring after many students have had the opportunity to practice it. And we will also use this in a second on some more difficult trinomial problems as we go forward. So let's take a look at an example here. Go ahead and stop the video and try sample problem 4. See if you can follow the process that I went through in the earlier example, and see if you can factor out these into two binomial parts. Okay, so if I'm looking at this, what I wanted to do with my initial factoring here is this. I wanted to break it up into two grouped parts. So I'm going to take the first part, x squared plus xy, and I'm going to break that up from the 2x and the 2y. So I've in effect grouped them off. I've broken it apart right there in essence, and I've grouped it off into two separate parts. Now, if I look at the first part, I notice that this has a common x that can be taken out. So I'm basically reversing the distributive process right here. So when I do that, I factor out a common monomial, and that leaves me an x right there and a y right here. So I've done this on the first part. I've factored out a common x, and I'm left with x times x plus y. If I look at the second group, I notice that I have a common 2 that I can take out. And it's a positive 2, so what I'm going to do is very important here that I bring out the plus sign with that. So when I factor out the common 2, I'm again left with x plus y. Now, this is an extremely important part of the process. We are looking in grouping to create a situation where we have the exact x plus y values on both parts. When we factor out these common monomials, we're in effect still have two separate terms. If we look here, I have this term, x times x plus y, as one term, and I have a positive 2 times x plus y as the second term. So if I'm looking at these two terms as a whole, they have a common factor that can be factored out. I can actually factor out the x plus y. Now, when I factor out the x plus y from the first one, I'm left with simply this x. When I factor out x plus y from the second term, I'm left with this positive 2, and then I am left with these two binomials, which represent the factored form of the original term. Again, if you wanted to double check this, you could FOIL these two terms together and you would be left with the original term at the beginning. So, factoring by grouping is a special factoring technique that we're going to use here in a second to help us factor more difficult trinomials. But it was important that you could see and understand the process on a simpler scale with 4 distinct terms, and so it's a little bit less confusing. Now, this is going to take lots of practice. If you don't get it the first time, that's fine. Just keep in mind that you're going to need to continue to practice this for it to be useful, and all of these factoring techniques are going to be extremely important as we move into Chapter 5 and Chapter 6 and Chapter 7 and Chapter 9 as well. So this one set of notes trickles through the entire second semester of Algebra 2. So all of these factoring techniques are going to be important to your success as we move forward into Chapter 2 and we start dealing with more and more difficult problems and different levels of polynomials. So let's take a look at how we can first use this grouping technique in factoring some basic trinomials. Notice, we're giving you a trinomial again, but the most important difference here is very simply the leading coefficient term. Notice in our example, the leading coefficient term is greater than 1. That is different than what we did earlier in these notes when we were factoring trinomials that had a leading coefficient of 1. When we were factoring trinomials with a leading coefficient of 1, we were only dealing with the outside constant term as far as finding the pairs and numbers needed to factor it. Well, now what's going to happen is we are going to have to deal with both the 6 in front of the x squared and the negative 6 as the constant. Now, unfortunately, over the years, whenever I was coming through Algebra 2, The way that we were taught to do this was through a guess and check method, where you went through a trial and error process of trying to figure out what were all of the factors of the leading coefficient, what were all the factors of the constant term, and trying to find the combinations of patterns that would work to give you the middle term in the trinomial. Unfortunately, this process can be very cumbersome, and it can take a very long period of time to come up with the right pattern. Sometimes you get it on the first time, sometimes it takes you 12 or more guesses, if you will, to get the right combination of terms. So if you can learn this grouping process well, it's going to save you a lot of time and trouble. So let's go through the steps here of figuring out how we're going to use this grouping process. What we're going to do in the first step is that we're going to take the first term, the leading coefficient, and the second, the last term, the constant, and we're going to multiply them together to get what we call our key number. Now, once we get our key number, negative 36, we're going to go through the same process that we went through earlier by trying to find all of the potential patterns of 36 that would multiply together to get negative 36 and then add together to get the 5 in the middle term. And so what happens is, again, you can start with your basic negative 1, 36, and then you could move on to 2 and 18, and you can see here that we're not getting close to that 5, so we would just keep working our way down. Now again, I would recommend using your calculator very wisely and proficiently here, and eventually what you'll get to is you'll get to a negative 4 and a 9, or a 4 and a negative 9. Now negative 4 and 9, or 4 and negative 9, both multiply together to give us the negative 36. But we need to figure out which combination of these two add together to give us a positive 5. And you can see that it's the negative 4 and the positive 9. So you can see that that's what we've done right here in step 2. We've made an effort to figure out which two numbers are factors of negative 36 that add together to give us a positive 5. Again, use your calculator effectively to make this process as quick and simple as possible. Now, this is where the grouping process begins. If you recall back to the previous example, we had 4 terms so that we could group it into 2 separate binomials. Well, we need to create that situation here. So what we're going to do is, we know that the negative 4 and the positive 9 created the 5. So we're going to take the 5x and we're going to break it apart into a positive 9 and a negative 4. So now we have created 4 terms. This is what we wanted to do to get our ability to factor by grouping. Now that we have 4 terms, we can treat this next step exactly like we did previously. We're going to take the 6x squared plus 9x minus 4x minus 6, and we're going to break it apart. And we're going to group it into 2 separate groupings. And you can see here in the first grouping, we're going to factor out a common 3x. In the second grouping, we're going to factor out a common negative 2. And then if you then look at each of these as individual terms, they both have a 2x plus 3 as their common term, so I'm going to factor out the 2x plus 3, which leaves me a 3x and a negative 2. And then I have my final answer of 3x minus 2 times 2x plus 3. And keep in mind, if you had written it like this, that would be just as good as well. It does not matter which order you put those in. So keep in mind either way. Now, how do we know if we're correct after this long, cumbersome process of grouping? Well, we could just simply FOIL back the 3x minus 2 times 2x plus 3, and we should come up with our original 6x squared plus 5x minus 6. So, what I think you will find after you do a handful of grouping problems is this process is much quicker than guessing and checking, which in my opinion is never a good way to do math. So, let's take a look at sample problem number 5. Go ahead and pause the video, and you can see that this has a leading coefficient greater than 1, so you'll need to use the grouping process. So go ahead and take your time to do that right now. Okay, so if you looked back at the previous steps, the very first thing that we wanted to do was find a key factor, key number. So the way we do that is we take the leading coefficient and we multiply it times the constant, which is going to give us a value of negative 30. Now, I could use my calculator effectively here, and I could take the negative 30, or the 30, and start dividing it by all of the potential factors, and 30 and 1. So I need to see which of these factors is going to give me a 1x in the middle. So we can clearly see that if I take 30 and 1, I'm not going to get 1. I'm either going to get 29 or 31 or something of that combination. So we're going to do 30 divided by 2, and that gives us 15. Again, 15 and 2 does not give us a 1. So 30 divided by 3, that gives us 10. But again, 10 and 3 does not give us a 1. So then I'm going to do 30 divided by 4, doesn't give us an even number. Then I'm going to do 30 divided by 5, and that gives me 6. So when we look at 6 and 5, we can tell very quickly that some combination of 6 and 5 would give us a 1. Now, the fact that the key factor has a negative in front of it, the negative 30, we have to take that into account. So we could say negative 5 times 6 gives us negative 30, and negative 5 times 6, and then we could have a positive 5 times a negative 6, and either one of these would give me a negative 30. What we have to figure out between these two is which combination of these when added together is going to give us the positive 1 in the middle of this trinomial. So we can see negative 5 and a positive 6 gives us the positive 1x. Now, we've found our terms. Now we need to create 4 terms out of these 3. So what we're going to ultimately do is we're going to break that positive 1x into 2 terms so that I can create a 4-term polynomial. So we're going to be left with 15x squared, and of course my 1x is going to be broken up into negative 5x plus 6x, and then of course I have to carry down my negative 2. Now, in doing this, I've created 4 terms, and this gives me the opportunity to do the grouping process. So 15x squared minus 5x, I can group that off. I can take the positive 6x and the negative 2, and I can group that off. Now, as I look at each of these individually, I can see here that I can take a positive 5 out of this first one. So when I factor out the common monomial 5, I'm going to be left with 3x minus, excuse me, I missed a term here. I need to actually factor out a full 5x so that I'm left with just a 1 there. So don't make the mistake that I just made and just factor out the number. Make sure that you take out the full term of 5x. So we're left with 5x times 3x minus 1. Now, the second term, we can see here 6x and negative 2 have a common 2 in place. So I'm going to pull out a positive 2, which is going to leave me again 3x minus 1. Now this is extremely important I wanted these two terms to be the exact same. So if I'm looking at this, I have term number 1 and term number 2, and what those two terms have in common is the 3x minus 1. So if I pull out the 3x minus 1, I'm left with 5x from the first term, and I'm left with a positive 2 from the second term. And I have my fully factored form of the trinomial. So that is the grouping process being used to factor a trinomial that has a leading coefficient greater than 1. This is going to take some time and practice to get accustomed to it, but if you do it and you learn how to do it well, it will save you a lot of time and heartache as you go through the remaining chapters in Algebra 2. So we've just gone through a long section of notes here. That covers all the different methods and ways of factoring. There are other methods